Hello everyone, welcome to my channel. In this video, we are going to see memory hints and formula sheets for operating system, which will be helpful for your UGC and computer science exam. Subscribe my channel for more videos. First, formula sheet 1, which is turnaround time equal to completion time minus arrival time, that is TAT equal to CT minus AT in a short term. Next formula, waiting time. To find out waiting time, we need to subtract burst time from turnaround time. WT equal to TAT minus BT. Next, to find out response time, we need to subtract arrival time from first response. To find out CPU utilization, we need to divide CPU busy time divided by total time and then into 100. Next, to throughput equal to number of process completed divided by total time. Next, to formula sheet 2. First, logical address. To find the logical address, we need to add page number plus offset. Next, physical address. To find physical address, we need to multiply frame number into frame size and then we need to add offset. Next, effective access time without TLB. So, effective access time with TLB, without TLB, in UGC net, many times they ask this question. Effective access time without TLB is equal to 2M, that is memory access time. Next, effective access time with TLB is EAT equal to H into T plus M plus 1 minus H into 2 plus T plus 2M. That is, H is TLB hit ratio, small t equal to TLB access time, M equal to memory access time. Next, we are going to see a hints for operating system. First, process versus program. Program is passive, that is stored in disk. Next, process, which is active, executing program. Next, hint, the program sleeps in disk and the process runs in memory. Next, process state, new, ready, running, waiting or block, terminated. That is NRRWT, which we can easily memorize as new rabbits run with tigers. Next is CPU scheduling algorithms. FCF is first come first serve. SJF, smallest job first, round robin priority. So FCFS is non-preemptive and then SJF is minimum average waiting time and then round robin time quantum used. So next priority starvation possible in priority. Next deadlock conditions. That there are four necessary deadlock conditions: mutual exclusion, hold and wait, no preemption, and circular wait. Here also they give a shortcut MHNC, that is my neighbor hungry. My hungry neighbor, right? Next, paging versus segmentation. Paging, which is fixed size, no external fragmentation, and it is faster. Next, segmentation, which is variable size, external fragmentation possible in segmentation, and user view memory. Next topic, thrashing. Thrashing is excessive swapping between RAM and disk, which happens when pages are insufficient. Hinges, system spends more time swapping than executing. Next, virtual memory, which uses disk as extension of RAM. Virtual memory gives the illusion of large memory. Next topic, semaphore, which is a synchronization tool. Types of semaphore is binary semaphore and counting semaphore. Semaphore controls the process traffic. Next, critical section problem, which requirements are mutual exclusion, progress, bounded waiting. The hint is one process at a time in shared data. Next, Biledi anomaly, that is more frames may increase page faults. When we increase frames, the page fault also increases, which happens in FIFO page replacement. So Biledi anomaly abinale, it happens in FIFO page replacement. Page replacement algorithms, FIFO, which is the oldest page removed, LRU least recently used removed, optimal, the best but theoretical. Next, file allocation methods. The methods are contiguous, linked, and index. Contiguous, which is fast access, linked sequential access, and then index is direct access. Next, types of operating system. Type of operating systems, the first one, batch OS, which is old IBM systems. Time sharing is a multi-user system. Real-time OS is the embedded system. Distributed OS example is network system. Next one, kernel. Kernel, which is a core part of OS, and types of kernel is a monolithic kernel and microkernel. The hint is kernel controls hardware and resources. Next, quick revision of RAID levels. These RAID levels also asked in UGC net as a match the following. First, RAID 0, it have the technique as stripping. RAID 1, technique mirroring. RAID 2 is the Hamming code. RAID 3, byte stripping. RAID 4 is block stripping. And RAID 5 is distributed parity. RAID 6 is double parity. RAID 10 is mirror plus stripe. And memory trick, which RAID 0 is zero production. RAID 1 is one extra copy, that is mirroring. RAID 2 is error correction Hamming code. RAID 3, third disk parity, that is byte stripping. RAID 4 is dedicated parity block stripping. RAID 5, most popular RAID, distributed parity. RAID 6 is double parity, two disk failures allowed. And then RAID 10, mirror plus stripe, that is fast plus safe. Next, context switching, which CPU switches from one process to another. It is a pure overhead, that is no useful work done. Hence, which switching costs time but produces no output. Next, dispatchers, which give CPU control to the selected process. Hint, scheduler chooses, dispatcher executes. Next, long-term, short-term, middle-term scheduler. Long-term functions is select jobs from disk. Short-term mode function is select process for CPU, and then function of medium term is swap process. That is long equal to job scheduler, short equal to CPU scheduler, medium equal to swapper. Next, race condition. Race condition is a multiple process access shared data simultaneously, which results depend on execution order, race for the same resource. Next, mutex versus semaphore. Mutex is locking mechanism, one process at a time. Semaphore, which is signaling mechanism, multiple processes possible. That is, mutex equal to mutual exclusion, semaphore equal to traffic signal. Next, IPC, that is inter-process communication. Methods are shared memory and message passing. Hint is process communicate either by sharing or messaging. Next, Banker's algorithm, that is deadlock avoidance algorithm, that is loan is guaranteed only if system remains safe. Next, safe state versus unsafe state. Safe state versus deadlock cannot occur. In unsafe state, deadlock may occur. Internal versus external fragmentation. Internal fragmentation wastes spaces inside the block. That is empty space inside the block. External is wasted or empty space between the blocks. Next, compaction. Compaction is combines a free space, free memory spaces into one large block. Combines free memory spaces into one large block. That is, it is used to remove external fragmentation. Next is disk scheduling algorithm. FCFS is simple. SSTF is shortest seek time. Scan is elevator algorithm. C-scan is circular scan. Next, fork system call, which creates a child process. Hint is one process between two. Next, zombie process. Zombie process is finished execution, but entry remains in process table. Dead but not removed. Next, often process. Parent terminates before child. Hint is child without parent, that is often process. Next, demand paging, which page is loaded only when needed. That is demand paging. Page fault is requested page not present in memory. Page missing equal to page fault. Next, locality of references types, temporal locality and spatial locality. Hint is recently used pages are likely to be used again. Next, spooling, which is simultaneous peripheral operations online, that is printer queue, which many users use one printer. Next, system call categories are process control, file management, device management, information maintenance, and communication. Okay, memory trick for to memorize these first letters PFDIC is please feed dogs in cages. Next, real-time operating system types hard RTOS and soft RTOS. Hard RTOS is deadline must never be missed. In soft RTOS, occasional misses allowed. Next, multi-threading benefits are responsiveness, resource sharing, economy, and then scalability. Next, user mode versus kernel mode. In user mode, limited privileges and then applications run here. In kernel mode, full privileges given and then OS runs here. Next, DMA, which is direct memory access that transfers data between IO device and the memory directly. Hint is CPU is bypassed during transfer. Next, aging technique prevents starvation in priority scheduling, hinges increasing waiting process priority over time. Next, last one, features and solution, which is software solution for critical section problem. It works for two processors, hinges users turn and flag variables. Thanks for watching this video. Kindly subscribe to my channel for related videos. If the video is useful, share with your friends. Thank you.